Good afternoon, everyone. My name is Gal Oshry. I'm a product manager at AWS, working on SageMaker. I'm here with Giuseppe, Senior Manager for Solution Architecture at AWS, working on SageMaker as well, and Babak, working as the founder and CEO at NinjaTech AI. And we're here to tell you about training plans and recipes in HyperPod that were announced at reInvent a few days ago. We'll start by talking about the challenges with training large-scale models. We'll then go into detail about training plans and recipes. We'll show you a demo showcasing those two capabilities. And then finally, we'll hear how NinjaTech is using HyperPod and training plans to do some really cool things. The demand to build and train large-scale models has increased significantly over the past few years. You can see that as you train bigger models with more data, more compute, more time, you can get better and better results. This is enabling both improvements in existing use cases, as well as completely new use cases that you couldn't do before. Now, I've shown a very similar slide the past few years, and it'll be interesting to see if this trend continues over the next few years. But you can't just easily train these very large-scale models. There are many, many challenges involved, and we'll talk about just a couple of them today. The first is that you want to use the latest and greatest hardware. You've heard at reInvent about some of the advances with new instance types with the latest NVIDIA GPUs, as well as Trainium 2 and other instances. Using the latest hardware enables you to train the models significantly faster. And this can mean the difference between getting your product to market faster or missing all the exciting new use cases that are being enabled. Another challenge is dealing with faults. Whenever you're training models at very large scale, things are going to fail. And you need to be able to quickly recover from those failures and get the training started again. Otherwise, you're going to be delayed too much. Another challenge is the timelines. Right? You want to get your product out there. You want to do the best on a new use case, or you want to beat the latest benchmark before someone else gets there first. So you want to have predictable timelines to be able to do the model training. At large scale, you also want to think about performance and how you can distribute your data and models across the large cluster you're training on to get the best performance possible and train quickly. And finally, you want to think about cost. Training these large-scale models can cost hundreds of thousands of dollars or more. And you want to make sure that you're using the cluster as efficiently as possible if you're paying for that large-sized cluster. And finally, you actually want to think about the data science team and how efficient they are and how unblocked they are in doing the training quickly. Right? A lot of customers tell us that that's actually the highest priority, and they want to spend more as long as their teams are not blocked and moving quickly. So based on these challenges, last year at reInvent, we launched SageMaker HyperPod. HyperPod helps you reduce your training time by up to 40% through resiliency and performance optimizations. So resiliency refers to when a fault happens during your large-scale training. HyperPod actually looks at the type of error that happened and decides how to best mitigate it. Maybe it replaces the instance completely and resumes the training automatically. And that can save a lot of time instead of you having to go and debug, figure out what happened, and decide how to address that issue. Second, HyperPod helps you distribute your model and your data across the cluster as efficiently as possible and helps accelerate your training at very large scale. And finally, even though HyperPod helps you manage your cluster and makes things easier than doing everything on your own, it's very customizable. You can bring in, you can use Amazon EKS or Slurm to do the scheduling. You can bring in your own frameworks and libraries and tools to observe the model training and anything else. But there's still some challenges, right? Today, if you wanted to go and train a very large model on hundreds of instances with the latest accelerators, it might be challenging to always get that capacity because it's in such high demand to get those instances, right? So with on-demand, you can take that risk, right? It might be available, it might not, and then your timelines might get delayed. Another option is to reserve the capacity and make long-term reservations. And that gets you the predictable timeline, but it means that if your training is not going on 24/7 for months at a time, you might end up with a cluster with fairly low utilization. and then you're paying for something that you're not fully using. So we wanted to figure out how can we help customers plan their training workloads to meet their timelines and budgets, right? Bringing the best of both worlds from these two paradigms. And that's why a few days ago, we announced flexible training plans for HyperPod. With training plans, you remove the uncertainty and a lot of the manual process involved in getting the capacity and compute that you need for your training. Training plans are powered by EC2 capacity blocks to help you do that, but with HyperPod training plans, it also automatically sets up the training cluster and the compute when the training plan begins to minimize that manual work and interventions that you need to do. So here's how that might look like. You specify your needs, saying which instance type you want, how many of them, how long you want to train that model, and when is the earliest that you can start the training. Right? You might not be ready today. You're still gathering data, tweaking the algorithm, but you know that next week you need to start training to meet that deadline. You can view the recommended offering for the training plan, and you pay upfront for it to reserve it. You can use the training plan in HyperPod, which is what we're focused on today, but you can also use it with the SageMaker fully managed training jobs. So as an example, let's say I know that I want 10 instances of P5 for 14 days starting December 10th. Right? I know I need 14 days to complete the model training. I might be able to get a contiguous segment of that capacity, but maybe it starts mid-December or later. With training plans on HyperPod, we might actually be able to find you 2 segments, 7 days each, that start sooner and end sooner, so that you can finish your training as quickly as possible, even if there's a break in the middle. So once I have the training plan, and I've set up my HyperPod with multiple instance groups, right, that can be of different instance types, for each instance group, I can choose to use a training plan or not, and which training plan. And then, when the training plan begins, right, on that December 10th, HyperPod will automatically scale up that instance group to use the training plan. It will run the lifecycle scripts that you've set up, and also, if you choose, do deep health checks to make sure the instances and the connectivity between the instances is working as expected. As the training progresses, if there's a failure in the middle, HyperPod takes care of that automatically, so the training resumes as much as possible, as quickly as possible. And with that break between the 2 segments in the middle, HyperPod takes care of spinning down the cluster and spinning it back up when the capacity is available again. So let's just recap a couple of the benefits of using these training plans. The first is that you get even easier access to that latest and greatest compute to train the models. You get the resiliency benefit of HyperPod, where if there's a fault in the training, it automatically mitigates it and continues. You get predictable timelines. You know exactly when you get the capacity available to start the training and until when. You benefit from the high performance that HyperPod offers with the distributed training libraries or any other framework that you bring in. And finally, you know the upfront cost from the very beginning of how much it would cost to get that compute and use it for the duration of that training. I'm now excited to bring in Giuseppe to tell you about a different challenge that customers face and how we're helping them optimize their training performance and get started even more quickly.
Thanks. Thank you, Gal. So it's great to see how HyperPod training plans help customers getting predictable access to accelerated compute instances within timelines and budgets. But when we speak to leaders from companies of all sizes that want to move fast with generative AI, they also ask us other questions. They have other challenges that ask us other questions. So which models should I use? How do I easily customize my models? So I want to customize the models. How can I go through the customization process? And if I choose to customize my models, how do I optimize my training workload, my training stack performance? And customizing foundation models represents a key differentiator. By using your own data, you can move from generic generative AI applications, which are using models that are trained on generic data, to generative AI applications that create real value for your customers, your business, your products by using your own data. So how do you go about customizing models with your data? A common technique used to customize foundation models is fine-tuning. With fine-tuning, you provide labeled datasets, which are annotated with additional context, to train a model on specific tasks like text summarization, question answering. You make it more powerful on addressing a specific task. But you can also leverage unlabeled datasets or raw data to maintain the accuracy of a foundation model for your domain by using pre-training. So, for example, a healthcare company can continue to pre-train their model using medical journals, research papers, articles, in order to make the model more knowledgeable, more accurate on the industry terminology, on the medical terminology. However, customizing and foundation models and executing fine-tuning and pre-training is a complex task. So first, you need to select the model that you want to use, which is a relatively easy task. Then you need to configure the framework that you want to use to run distributed training on the chosen infrastructure. And here we can see many frameworks like DeepSpeed, Hugging Face, NVIDIA NeMo, even standard PyTorch that need to be configured in the appropriate way with the additional dependencies, libraries, drivers to build a stable runtime that we're going to use to run the distributed training. Third, you want to optimize model training. This is where you need to make sure that you appropriately configure parallelism techniques like tensor or context parallelism to support large context lengths. Apply memory saving techniques, these models, and according to how you train the models, you might want to optimize how the GPU memory gets utilized during training. Choose checkpointing saving frequency, as Gal mentioned. Failures can happen during training. You need to make sure that you save the state of the training with the right frequency to recover from the last checkpoints when you will restart the training. Do maybe some optimization of the hyperparameters and tune some other configuration. So this is where you're going to spend weeks of iterative experimentation to identify the best configuration that you want to use to run your distributed training. And once you have identified that, you move into production, pre-training, and fine-tuning, which is where you need a reliable and fault-tolerant infrastructure to run distributed training for weeks or even months, and that's where Amazon SageMaker HyperPod helps. But at the same time, as I already mentioned, you need to have in place checkpointing, and you need to make sure that you can restart the training from the last checkpoints when needed. So overall, if we count the number of options that I just mentioned, for each of the tunable dimensions, so 3 to 5 popular frameworks, then you have dozens of tunable parameters, hundreds of configurable settings there, plus some other optimizations that you might want to do on the distributed training libraries, you can see how you can easily reach thousands of different configurations of the training stack. And training performance can vary significantly based on the chosen configuration. So this complexity often leads to project delays, suboptimal model performance, and budget overruns, even for experienced teams. So there's a clear need to simplify configuring and optimizing foundation model training without sacrificing performance. And that's where Amazon SageMaker HyperPod recipes help. Let's see how. So the new Amazon SageMaker HyperPod recipes empower data scientists and machine learning engineers to accelerate the work with the foundation model. We provide curated, ready-to-use SageMaker recipes for pre-training and fine-tuning popular, publicly available foundation models, such as Llama 3.1, including the 405 billion version, Llama 3.2, Mistral, Mixtral, and the recipes will evolve as foundation models continue to evolve. The recipes allow you to start pre-training and fine-tuning in minutes instead of weeks, and leverage the optimized performance, scalability, and resiliency of SageMaker HyperPod. This recipe provides efficient resource utilization, and as a consequence, cost optimization for your training workloads. We take care of implementing end-to-end training loop for SageMaker optimized models, which include automatic model checkpointing techniques. As I mentioned, checkpointing is a very important task. We're doing it automatically for these models without additional code changes. You don't have to worry to change any line of code to do checkpointing. thus enabling you to save in-progress model results at high frequency and quickly recover from faults. So these recipes for sure can be easily customized, and you can adapt models to different sequence lengths, model sizes, and you can easily switch, really simple configuration change from using GPU instances as well as other accelerators like Trainium, so Trainium-based instances. So let's see how it works. How do you get started? So the first thing that you have to do is select the recipe that you want to use for pre-training or fine-tuning. The recipes are available in a public GitHub repository, so that contains all the list of recipes. This is where you will select the recipe. Then you set up the prerequisites. So you need to make sure that you have your infrastructure up and running, so your HyperPod cluster up and running to execute the training. So you will set up the limits and all the configurations that need to be in place to spin up your cluster. And finally, you run the recipe on the HyperPod cluster, but the recipes can also be run on SageMaker training jobs if you are familiar with the ephemeral training jobs that can be run in SageMaker as well. So how do you launch? How do you execute training and fine-tuning, pre-training and fine-tuning through recipes? There are a few ways. So we have built a NEMO-style launcher. For those who are familiar with NVIDIA NEMO for training, this will definitely look familiar. We have also built some launcher scripts which leverage the NEMO-style launcher but set some parameters automatically so that you don't even have to build the NEMO command by yourself, NEMO-style command by yourself. And this is very convenient when you're running training with HyperPod clusters orchestrated by Slurm. In addition to that, we have extended the HyperPod CLI that is used to work with EKS orchestrated HyperPod clusters to support running pre-training and fine-tuning with the recipes. And finally, to run on SageMaker training jobs, we have updated the SageMaker Python SDK. So there's a new class that's called Model Trainer that supports running training with recipes, but we have also updated the existing estimator classes in the SageMaker Python SDK. Practically speaking, as I mentioned, the recipes are contained in a public GitHub repository, which contains the launcher scripts and the recipe collection. In addition to that, this recipe contains the actual launcher, the implementation of the code that will execute the training, as well as the configuration hierarchy. And there are over 30 recipes to get started. With this framework, with this launcher, you can execute pre-training and fine-tuning with SageMaker GPU-optimized models, with neuron-optimized models when you run on Trainium infrastructure, but it also supports running native NEMO models, as well as bring your custom model. So bring your custom recipe and model. It's an extensible framework. This is an example of a recipe. On the left side, you see a recipe that can be used to do some pre-training of a Llama 3 8 billion model. And as you can see, there are a few settings like tensor parallelism, expert parallelism, context parallelism, which are pre-configured. So you don't have to worry about discovering the optimal configuration by yourself. But these are tested, validated, and bring the cost optimization and performance when running on AWS infrastructure. And on the right-hand side, you see also another configuration file, which is available as part of the recipes, in the recipes collection, which is where you will configure the infrastructure. This configuration structure is based on Hydra, which is a popular framework for configuring applications. And at runtime, then the configuration gets merged to build the final configuration file. And you can also override specific configuration using command line arguments. That's how Hydra works. As I mentioned, for SageMaker GPU-optimized models, we are defining training loop, data loading, and automatic checkpointing code. And this is done through so this is implemented in another repository, which is called SageMaker HyperPod Training Adapter for NEMO, which is the repository that contains the actual training code that will be executed at runtime based on the recipe that you choose. And it's there that we are also implementing the optimizations for distributed training using the SageMaker distributed training libraries like SMP, SageMaker Model Parallelism Library. And this is still built on the NVIDIA NeMo backend. So let's put this all together into a single architectural slide. We can see here the job submission workflow. And the way it looks like is that the user can choose to work with the NeMo style launcher or the HyperPod CLI or the SageMaker Python SDK, depending on the target infrastructure for training. Then the launcher, which is in SageMaker HyperPod recipe repository, will parse the model configuration from the recipe, get the training code, we'll see how, parse the cluster configuration, including the container that you want to use to execute the distributed training, then create the final launcher scripts and execute the code, the training on the target infrastructure, launch the job on the target infrastructure. Depending on the model that you're using, if for SageMaker optimized models for GPUs, it will use the Amazon SageMaker HyperPod training adapter for NeMo for the training code. For neuron optimized models, it will pull the training code from the NeuronX distributed training repository, and native NeMo models from NVIDIA NeMo. And as I mentioned, you can also bring your custom models. I think it's worth seeing this in action. Let me move to a demo. Let me run a demo, and this demo will combine both training plans as well as recipes. So what we're going to do is we're going to use a HyperPod cluster which is running on an active training plan to execute the recipes. Okay. Just give me a second. Great. So I am here on the landing page of Amazon SageMaker AI, and the first thing that I want to show you is how to work with the training plans. Okay. So this is the training plans screen, and the first thing is let's try to create a training plan. Training plans work for both HyperPod clusters as well as training job. So let's say I want to create a training plan for a HyperPod cluster. Next thing I'm going to do is selecting the instance type that I want to use. Let's say I want to pick the P548XL, which comes with 8 NVIDIA H100, sorry. And let's say I need a couple of instances, okay? You can then specify the start date, the earliest start date for your training plan, and potentially an end date, so by when you want your plan to be, your workload to be completed, and the duration, the expected duration of the plan. Great, let's try to find the training plan. And as we can see, we get a matched plan, an offer, which consists of a single segment of a duration of 4 days that will start on December 7 and will end on December 11. And the other thing that we have to note is the availability zone, because this is where we are going to create the HyperPod cluster to use this capacity. We need to make sure that our cluster is created in that availability zone. And we also get the total upfront cost, so it's, you get visibility, upfront visibility into the cost and the price breakdown. So I can go to the next screen, just put a random name, my plan. You can add tags as for the other SageMaker resources, and finally you can review, and last screen you review and decide whether purchasing this plan. One thing to note is that plans cannot be modified once purchased, and at the moment I'm not going to create a new plan. I already have an existing plan, so just go back to the screen, and as you can see here, I have a list of plans. Some are expired already, some are active, and one is in the scheduled state. One thing to note about the scheduled state, so after a plan is purchased, it goes into the scheduled state until it's reaching the start date of the plan. But you can already use the plan with a HyperPod cluster, even if it's in the scheduled state. So you can create the HyperPod cluster, associate the plan in the scheduled state, and then the instances, the instance group will be spin up automatically when the training plan is activated. In this case, for this demo, I'm going to use this training plan, which is training plan with 4 P5 instances, which is in active state. You can check the details here. And let's see how the training plan works with the HyperPod cluster. So before I move to my running HyperPod cluster, I want to quickly show you how to create an HyperPod cluster and associate a training plan. I'm choosing to create a cluster with orchestrated by Slurm. Let's put a name. And the place where you are going to associate the training plan, as Gal was showing in the slide, is when you create the instance group for your cluster. Typically, for Slurm clusters, you create a group of instances as login nodes, a group of instances for the controller, and a group of instances for the worker nodes. So here it will be where we will associate the training plan. So let's say I have my worker group here. I select as instance type the P5 for which I know that I have a training plan, and let me put a couple of instances, and as you can see here, we can select on-demand capacity or the training plan. You can point the instance group to the training plan so that it will pick the capacity from the training plan, from the active training plan. Again, not creating the cluster now. It will take some time to create the cluster. It would take some time to create the cluster, but I already have a running cluster, which is called ML Cluster Training Plan, which, as you can see, is running with a worker group, which consists of 4 P5 instances, which are coming from the training plan. So from the AWS console, now we have this new column here in the table of the instance groups, which gives you evidence that these instances are coming from a training plan. And this cluster is up and running now, so we can try to use this cluster. Great. The way to do that, so one way to do that, I have connected my VS Code, my local VS Code, to the login node of this HyperPod cluster. So HyperPod cluster allows you to establish an SSH connection over a secure SSM tunnel, so AWS Systems Manager tunnel. So I have the remote connection already in place, and if I look at where I am in the user home directory is set on the FSX file system. So this cluster has also an FSX file system attached. So let's see what is in this file system at this point in time. And what I have is, I have data sets here, and I will be using the Allen AI C4 dataset. It's a curated version of the common crawl dataset for the training. And it's already tokenized, and I have a training dataset here and a validation dataset here. Great. The other thing that I want to show you is the images. So when working with the HyperPod recipes, as we mentioned, we also provide, the runtime that you're going to use for distributed training, okay? So this comes in the form of a Docker container, but when running with the Docker on Slurm clusters, it's convenient to convert the Docker container into an unprivileged sandbox using enroute. It's a technology that allows you to convert Docker container in unprivileged sandboxes, and this is what is convenient to do, what is recommended to do with Slurm clusters. And we also provide pre-built enroute image that you can download. It's linked in the HyperPod recipes repository, which is the one that I'm going to use for this demo. It's this one. Great. Let's take a look now at the content of the HyperPod recipes that I have cloned on my local FSX file system. First of all, in the recipe collections, we can take a look at the config.yaml, which gives you information about the configuration of the infrastructure. So I'm going to use Slurm here. And one thing that I had to set was the container that we want to use to run training. It's actually the squash file, the enroute image that we are using here. The other thing is in the cluster configuration, the other change that I have applied is I have edited the container mounts so that when the container will be run on the cluster, the FSX file system is also mounted to this container, because I have to read data, I have to save my results on the local file system. Great. That said, the recipe that we are going to launch today is a fine-tuning of Llama 3 8 billion with 8K sequence length on GPUs. because I have my P5 instances. And this is the definition of the recipe, okay? So you find the configuration for the training, configuration for experiment tracking. HyperPod recipes allow you to track experiments automatically in TensorBoard format. So you can then use TensorBoard to visualize the experiments. And the other thing is, here you can see the model configuration that I was showing also on the slide. So all the settings about parallelism, which are pre-configured in the recipe, as part of the recipe. And then, as I mentioned, we also provide the pre-built launcher scripts to actually trigger the training. These are shell scripts, which are in the launcher scripts folder, llama, and then we have to find the right one, which is this one. And the thing to note here is that there are a few variables like experiment dir, train dir, validation dir, Hugging Face model name or path, and Hugging Face access token. This is a fine-tuning exercise, so we're going to also pull the model from Hugging Face to execute the fine-tuning. Okay, that said, let me trigger the fine-tuning. I have a few commands in my notes here just to make sure that I get it right, but first thing that we have to do is to set the Hugging Face token, and then we are activating the virtual environment for the HyperPod recipes that I'm using for the launcher of the HyperPod recipes. Then what I will do is I will move to the SageMaker HyperPod recipes repository, to the local directory, and then we can set these environment variables. So the Hugging Face home, the Hugging Face model name that I want to use for fine-tuning. Then these are the locations where my data is stored. So the training dataset, the validation dataset, as well as the target location for the experiment tracking. Let me set these other variables, and finally, the only thing that I need to do in really a single line of code to execute the fine-tuning is launching the fine-tuning with the launcher. As you can see, what happens is that the final submission scripts gets built by the launcher, by the HyperPod recipes launcher, and then the job is submitted to my Slurm cluster with ID 61. We can take a look at the outputs that are produced by this job. We'll take a few seconds to see something on the screen. But in the meantime, while the outputs are generated and the training starts, what I want to show you is also TensorBoard logs for some existing runs that I have pre-executed. And here I'm using the Manage the TensorBoard feature, which is available as part of SageMaker Studio. So in SageMaker Studio, you can also host and manage the TensorBoard. And I have connected this TensorBoard to this specific path in S3, which is where I have synced the FSX file system to. So Amazon FSX allow you to set up the so-called data repository association, so you can sync some data in S3 back and forth with the FSX file system. FSX provides better performance when it comes to large-scale distributed training. That's why with the HyperPod, many times it's a convenient way to execute, to store your data for an HyperPod cluster. Great. I have synced that, and if we move to the time series section for TensorBoard, you can see some of the past experiments that I have run for just a few steps, 50 steps. It was just an example. Great. Going back, we can see that the training has started. So it will, take some time to run the various 50 steps. The thing that I want to show you is maybe I can show you some results from some past run. This is job number 60. It's a similar run, and these are the kind of outputs that you should expect from the recipe. Here we are loading the checkpoint shards because we're doing fine-tuning, and then there's the code. The actual training code is here, running the various steps, stopping at step 50, around step 50, and saving the checkpoints to the target location of the checkpoints that I have specified. So this concludes my demo. And now I'm happy to invite on the stage Babak, who is going to talk about how Ninja Tech AI is using training plans to innovate. Please. Please.
Thank you, Giuseppe.
Thank you
very much. All right. So, Giuseppe, I'm going to give you your laptop back, right? Yeah. So, there we go. And I just need the HDMI cable. Do you guys know where that is? Let's see. If any of the AV folks can give me the HDMI cable while I'm talking, that'd be great. So, thank you. It just, I don't know if it, yeah, it probably needs the HDMI to go there, but we'll see it up. So, well, good afternoon, everybody. Oh, maybe it did work, huh? Okay, we'll find out. Thank you. Well, how's everyone doing? This is this is almost the end of reInvent. Hopefully, everyone is ready to go home, but also let us share with you something really cool as Gal and Giuseppe were going through this. So, in a nutshell, let me just, I've learned what when you do presentations, you kind of cut to the chase and then make the story how to get there. So we are a Gen AI startup. We are a 2-year-old startup out of SRI. I was at Google for 11 years, and then I came out, and we decided to build Ninja Tech AI, which is an all-in-one AI agent for unlimited productivity. In essence, we're trying to be sort of the Netflix of Gen AI. So one all-in-one solution, one simple subscription service, all you can eat, the best AI agents and best AI models and AI skills. That's our goal, that's our target. In a sense, there are a lot of solutions that people can buy that are $20 a month, $30 a month from flagship sort of models or niche sort of AI solutions. Our goal is to just give our users one unified UI. You all can go to myninja.ai is the product. And we have subscriptions for $5, $10, $15, all you can eat. And we're going to continue to add new models. Like as of next week, we're going to roll out Amazon Nova inside our system, all you can eat with different tiers, as well as different AI skills. So in a nutshell, the way everything works is about sort of when a user comes in, they put in a query, we right out of the gate, we try to do intent analysis using our specialized fine-tuned AI model. And depending on what the user is asking for, we try to activate different AI agent or AI model automatically. So these are the sort of the different variations of different types of tasks that we support. So writing, brainstorming, coder, researching the multi-step online, scheduling meetings, image generator, image editor. Soon we're going to have video, music, audio, you name it. And it's not just about giving AI sort of unlimited access, but also we have a special technology that we're calling super agents, I'm going to touch on it later, that allows us to combine different AI models and actually elevate quality and intelligence. We in fact launched it at reInvent earlier this week. It's on our website. Go check out our benchmarks. And we've been able to set a state-of-the-art landing for Arena Heart, which is the quality of chat, and sort of the top 2 skills that we have, as well as on math, coding, and reasoning. Our different tiers of the model are actually overpowering their peers. But in order to do this, in order to do what we do, the critical need for us is to be able to automatically detect the user's intent and also be able to fine-tune quickly. We have tens of thousands of users daily that are using the product. Some days it goes up to over 100,000. And overall, it's over 1 million MAUs. And we have an excess of something close to like 50,000 tasks daily that get done through our infrastructure. So we have a lot of data that we try to then use to further fine-tune the models that we have. And in order to do all of this, that's a critical need. We need to have access to high-performance GPUs, ideally in an affordable way. We're a startup. and be able to plan it and also run through a training process. For those of you guys that do training or fine tuning, you know that it's a royal pain in the neck, especially when your model is as large as ours. We are using 405B as our core engine. So we're on a 5th generation of it. We've been fine tuning it, and it's to be able to do at the scale that we're operating, it's quite difficult to be able to pull it off when you don't have like hundreds of engineers to throw at it, essentially, to do ML ops and hand-holding up training and whatnot. And this is the sort of the cut to the chase part of the story. HyperPod recipes, it turned out not to be vitamin, but actually penicillin for what we do. I can't recommend this enough. Essentially, the value prop is undeniable at this point. And probably just like you guys, we were a little bit skeptical. We were like, well, you know, can I do this on my own? Or do I really need these solutions? And it turns out you absolutely do, especially if your model that you're fine tuning is very large, because it makes life a lot easier and you end up saving a lot of money. In our case, it actually would enable to do certain type of training that we couldn't do as a startup before, in which you need to do multi-node training with self-recovery capability. There's been times that even if we could get our hands on H100s, we would have to stay up, like pull all-nighters, people watch all the nodes, because as they would break, we would have to do manual checkpointing and recovery. This finally solves that for all of us, and it's just incredible, essentially the value prop here. Now, let me show you a quick little demo of a special thing that we did using a HyperPod recipe. Let me see if I can connect this. So let's see, there we go. So you all have seen, there are other products in the marketplace, let's just call it ChatGPT. There's a conversational mode to it, right? The core system that we do is powered by open source models, and we fine tune them, right? So Llama, as you guys know, it's not, it doesn't understand conversational tokens, right? It's just text in, text out at this point, right? So we, using HyperPod recipes, we were able to train a variation of Llama model to make it actually voice conversational. This is the first time ever we were able to do this, and we did this using this multi-node configuration. So let me just do a quick little demo, and let's see, internet cooperated me. Are we online? Yes. Okay, sounds good. Hey, can you hear me okay? Were you able to hear it?
I'm a friendly voice AI, and I'm here to help you with any questions or problems you might have. I'm not a real...
Well, I'm here with a good friends of ours, the audience in the AWS reInvent. Can you say hello to them real quick?
Hello, everyone. I'm Ninja Tech, a friendly voice AI here to help you with any questions or problems you might have. I'm designed to make your life a little bit easier, so feel free to ask me anything. I'm here to help with all sorts of things, from answering questions to giving advice and more. So, what's on your mind?
Well, they're curious to know if you're feeling good today or not.
Well, I'm feeling great today. Thanks for asking.
Does that mean you're alive?
I'm always happy to chat, feeling pretty happy, and ready to help. I'm a computer program, so I don't have a physical body. I exist only as a collection of code and data that's running on a computer, but I'm designed to be very helpful and friendly. So I like to think of myself as being alive, in a way, even though I'm not a real person.
Oh, pretty cool, right? So let me go back. So that kind of training as a startup we couldn't do before. We usually do LoRa or QLoRa, but using HyperPod recipes, we were able to do a multi-node configuration for training. This took about like 14 hours to train this, and we did it with only just a few $1,000s, and that was it. It was like less than $5,000 worth of cost for this. This is why we mean this is penicillin. Does it make sense though? Like now, I mean, now this is a llama model that you can actually talk to. And to be clear, we're not cheating. We're not doing speech to text and then get text. And this is actually understanding voice tokens essentially. So, but this is the kinds of things that this allows us to do when we fine tune. We're able to use it in our core technology, which is the super agent, which it's on our website. You guys can go check it out. It's already live in the product. We rolled it out as of Monday. And it's a whole new way of looking at agentic compound AI, because now using the system that we have, we can now leverage a variety of models all at once, do inferenceable optimization in real time, and then boost quality. The benchmarks are published on our website. Yeah, even our turbo version, which is completely using everything in-house, everything that we fine-tuned, on certain benchmarks like reasoning and math, we are already overpowering flagship models. And that's something that we're very, very proud of. And we're going to continue to double down here. As new models come out, we're going to add them to our recipe, we're going to optimize them, and then the end result is that users don't have to think about which models to choose. They just use Super Agent, and Super Agent provides the best answer possible. And this is sort of one of the benchmarks that we were really proud of, but also pleasantly surprised that using this technology in Arena Hard benchmark, we were able to set a state of the art. It's even overpowering O1 Mini and O1 Preview. OpenAI announced O1. Obviously, we don't know the score for Arena Hard for O1 itself, but as of earlier this week, we were considered a state of the art, our apex tier of the Super Ninja. So to recap, but it all kind of goes into this, but the core value prop, the core systems that you need are systems that are easy to set up in order to do training or fine-tuning, affordable, you can do reservations ahead of time, and then easy to leverage HyperPod with it. HyperPod is an incredibly powerful system, as you guys may know, but it can be difficult to use. You need like a lot of knowledge of how to use it properly. The HyperPod recipe actually made it like just a breeze. It made it super, super simple. And the advantages that we observed by doing this were the capacity reservation, just that by itself, and a discount that we can get. Because as you know, you don't do training every single day. You set up your training script, and then you say, okay, I want to do it on Monday, and that's it. Tell me how to do it, and then it does it. It automatically terminates the instances when they're done, so you don't pay more. You manage the VPCs all seamlessly, and then the recipes are godsend. You just take the recipe, add your sort of training the instructions to it, and then you just go. And then ultimately single UI and support, the support that you get from the team. I can't recommend it enough. It's something that was during the alpha phase. We could do things that we couldn't do before, and I think that now our approach for training has completely drastically changed as we go forward. So you're more than welcome to try the product. It's called MyNinja.ai, and we are completely an AWS shop. And it's been a delight working with the team, Gal, Giuseppe, and the other sort of the crew that's behind the scenes. And feel free to ask us any questions. So yeah, thank you very much. That's it.